taking a piece of raw information and transforming it into clear, focused insights that you can actually use. If you're the kind of person who loves understanding how things are built from the ground up, well, you are in the exact right place today. We're going to be breaking down a very specific fragment of an educational curriculum. We're looking at a quick snapshot that dictates the foundational concepts of junior level mathematics. It's a really short fragment, but as you'll see, it reveals this incredibly deliberate blueprint for learning. Okay, let's dive into this. We're going to anchor our entire analysis today on one central guiding question. What exactly do junior levels focus on? Think about it. When educational designers sit down to map out a young mathematical mind, what are the absolute non-negotiables? What are the core pillars that they believe just have to be established before anyone can even think about moving on to higher level algebra or advanced calculus? Well, we are going to answer that by looking directly at the source material. And here it is. This is the exact source document we're analyzing today. It's really just a fragmented glimpse, literally a single partial sentence, captured from a much broader curriculum document. You can see topics like percentages, decimals, perimeter and area, ratio, volume, data handling, and symmetrical shapes. Now, it's incredibly brief, for sure, but it is densely packed with core cognitive development milestones. Every single item on this list represents a massive foundational step in classroom instruction. Now, if we act like an investigative lens and zoom in right at the end of that snippet, we see the incomplete word focus. And that's actually absolutely crucial. This isn't just some random assortment of math terms pulled out of a hat, right? This is the stated, deliberate focus of a junior curriculum. It's the core agenda. By decoding this specific list, we can see exactly what educators prioritize and how they plan to structure early mathematical education. So let's extract the raw topics. We get percentages, decimals, perimeter and area, ratio, volume, data handling, specifically noting average, and symmetrical shapes. Stacked up like this, these aren't just isolated, boring subjects. They're actually exciting educational building blocks. They are distinct tools handed to a young learner to help them interpret the real world around them. So let's see how these blocks connect. Let's move to Section 1, Numbers and Proportions, the Foundations of Value. You know, what's really interesting here is how grouping percentages, decimals, and ratio reveals a very clear curriculum emphasis. By placing these three together, the curriculum aggressively targets foundational number sense and proportional reasoning. Think about it. A decimal is a part of a whole, a percentage is a part of 100, and a ratio compares two quantities. This tells us something huge. The junior level isn't just about counting whole numbers anymore. It's making that massive cognitive leap from just asking how many to figuring out how much in relation to something else. Moving right along to Section 2, Geometry and Measurement, Exploring Space and Size. And this brilliantly illustrates how the curriculum addresses the physical, spatial world we live in. Over on the left, we've got a purely spatial visual concept, symmetrical shapes, so recognizing patterns, seeing balance. But then on the right, it's immediately paired with highly quantifiable concepts, perimeter, area, and volume. So the learner first visually recognizes the shape, and then, boom, they are given the tools to measure its boundaries, its flat surface, and its 3D capacity. It outlines this beautiful progression from just seeing a shape to mathematically defining the whole shebang. Finally, let's hit Section 3, Data Handling Focus, Analyzing Information. So the crucial point here is how the text specifically says data handling average. That little parenthetical detail, it's a highly precise indicator of what data handling actually means at this stage. It tells us that at the junior level, we're not worrying about complex scatter plots or standard deviations yet. No way. It is laser focused on central tendency. It's teaching a young mind how to look at a chaotic, messy set of numbers and find that single representative middle ground. Honestly, that one word is the vital anchor for this entire data segment. So we've taken a single fragmented sentence today and uncovered a highly deliberate structure: proportional reasoning, spatial measurement, and central data analysis. Which leaves us to ponder, how do these specific foundational blocks shape advanced problem solving later on? I mean, when that learner eventually faces statistical modeling or calculus down the road, how much of their success traces right back to this exact focus on decimals, volume, and averages? It's like a giant puzzle. Keep that question in mind as you explore more educational structures. Thank you so much for joining me for this explainer. And as